Hello everyone, I am Snigdha Kakkar and this is my channel AccelerateAICareers. Today we are going to discuss a very interesting LeetCode problem, LeetCode 78 subsets. It is one of most favorite questions for several fan companies such as Meta, Amazon, Microsoft, Google. It is also asked by Apple and Netflix in their interviews in last 6 to 12 months. So let's see what does this question say. So we have been given an integer array nums of unique elements. There is no duplication there, and you have to return all possible subsets, the power set basically, of comprising of all subset possible from those elements, those unique elements given in the nums array. The solution set must not contain duplicate subsets, that is 1, 2 and 2, 1 is considered to be the same subset. So the permutation doesn't matter and they should occur only once, they should not repeat themselves just by changing the permutations. And you have to return the solution in any order. There is no specific order they are expecting. For example, you have been given nums as 1, 2, 3. With every step, say suppose with 1 if we are talking about, we have two decisions to make. Either we can choose to have 1 or we can choose not to have 1. So we make two decisions. Same way, for 2, we can choose to have 2 or not to have 2. So two decisions. And same way for 3. So in all, we are making 2 into 2 into 2, that is 8 decisions. And with those 8 decisions, we have 8 number of subsets, but we don't need this count. We actually need the subsets listed out. Just for your information, these are 8 subsets. That is, your time complexity would be O of 2 raised to power n, where n is the number of elements in your, but the time complexity will also depend on the length of each subset. So the maximum length in worst case scenario for your subset could be n, that is all the elements present is also a good adequate subset, right? So n into 2 raised to power n would be your time complexity in worst case scenario. Now, what would be these subsets? So either you will have empty set, that is no element included, because an empty set is always a subset, right? And then you can have solos, that is 1, 2 and 3. You can have doublets, that is 1, 2, 1, 3, 2, 3. And then you can have the entire array as a subset 1, 2, 3. If you count, you have total of 8 subsets like I pointed out here. Let's look at example 2. So in example 2, nums is just with one element 0. And with one element 0, that means you have two decisions to make. Either you select 0 or you don't select 0. So you will have total 2 elements and those would be either empty subset or it would be 0. The approach we are going to use to solve this question is backtracking. So we initially start with our entire array. Then we choose any one index element. Say I choose index 0 element 1. I either choose to go with it or I choose to skip it. So there are two decisions I make. Then if I choose to go with it, then my next array is 1 as shown in green here. After that, I make my second decision if I choose to include 2 or skip it. If I choose to include 2, then my second subset becomes as 1, 2. If I choose to skip it, then my subset becomes 1. Then there is a third decision which I make to include 3 or skip 3. So if I include 3, then my subset is 1, 2, 3 as shown in red here. If I choose to skip it, then my subset would be 1, 2. Now here, when I chose to skip 2, then my subset was 1. And if I choose to include 3, then my subset is 1, 3. If I choose to skip 3, then my subset is just 1. Same ways here, when I skipped 1 and I had an empty array here, then I chose to either go with 2 or skip 2. If I chose to go with 2, then my array would be just 2. If I chose to skip 2 even, then I would still have an empty array. Then again, I'll have two decisions to make, either to include 3 or skip 3. If I include 3, then my final subset would be 2, 3. If I choose to skip 3, then my subset would be just 2. Same ways, if I choose to include 3 here, then my subset would be just 3. If I choose to skip 3, then my subset would be an empty subset. And if you see the subsets written in red here are the final subsets. And if you count, there are 8 subsets and we have covered all the scenarios. This approach is backtracking. Either we choose to go ahead with 3 or we take a step back and exclude 3. And that's how we proceed one step and then we backtrack, we take a step back and go ahead the next route. And that's how we are finding all the solutions. So since we are making 2 decisions at every step and we have taken 3 steps, so the time complexity is 2 raised to power 3, that is 8. It would be O of 2 raised to power n and multiplied by n because the maximum length of subset we have is 3 here. So O of n into 2 raised to power n would be your time complexity. You just have to code keeping this decision tree in mind. So let's start coding. First of all, I'll initialize my result list, which will capture all the subsets. After that, I write my nested DFS function, depth first search function for backtracking. Depth first search function, my input would be my index, that is the element I'm across in the nums array. And before that, I'll also initialize my temporary subset, which I will be working upon with an empty array. Okay. I'll check if I has reached at the end of the array. So if I is greater than length of nums, what do you do? In that case, you just return. But before returning, you have to append that subset to the result because you have crossed the nums array entirely. So subset, but this temporary subset could change at every step, right? Because you're doing backtracking. So instead of saving subset, save a copy of that subset. Afterwards, there are 2 decisions you can make. Either you can take decision to include nums of I, or you can make a decision to exclude nums of I. So when you choose to include nums of I in backtracking, what do you do? In that case, you append nums of I to your temporary subset and then you call DFS for I plus 1. If you choose to exclude nums of I, in that case, you do not append anything and you directly call DFS I plus 1. So for both DFS I plus 1, it seems same, but the behavior would be different. In one, you are appending nums of I. In the other one, you are not appending nums of I. But here, before calling DFS I plus 1, you have to pop the element nums of I from subset because you are excluding it and it was already added on the top. That's how backtracking works. And finally, there is nothing else to do. You have to just initialize DFS function from 0th index and you have to return the result. So let's run this code. It's accepted. Let's submit. As you can see, it is working well. So now let me just summarize the code for you. So I first initialized my result array. I also initialized a temporary subset array where I'm capturing the current subset. And then I wrote a nested DFS function with an input of index value to it. That is the current index of the element I add. So I check if I has crossed the entire length of nums array. If it has, I append my current subset copy to my result array. That's what I have done. Now I have 2 decisions to make at any point of time. Either I include nums I or I exclude nums I. If I include nums I, then in that case, I append nums I to my subset. If I exclude it, then I just pop it because it's already included on the top, right? And then I call DFS I plus 1 because it's recursion or backtracking, then we have to call the next variable DFS on that. And finally, I initialize this DFS function with 0th index and I return the result. So that's my entire code. The complexity I've already told you in worst case scenario would be O of n into 2 raised to power n because at every step you're making 2 decisions, whether to include an element or exclude an element. And in all, you can have maximum to maximum n elements in a subset, hence this time complexity. The space complexity would be O of 1 since we are not using any additional space here. Now, if you have any questions, ask them in the comments here. I'll be happy to address them. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.